Alright, hello Algebra 2. You are my guinea pigs, so hopefully I've got the room at the right brightness where you can actually see the Jamboard. Fingers crossed, and hopefully it's not flipped the way it looks on my screen, so hopefully this works. If it doesn't, shoot me an email and let me know. So today we're looking at writing linear equations, and we're used to seeing linear equations look like y equals mx plus b. So you've got slope-intercept form, this is slope, that's your y-intercept. This is not new. So if we want to write an equation in slope-intercept form and we have, say, our slope and our y-intercept, so if we have a line that passes through 0, -7, which is your y-intercept, because 0, -7 is along your y-axis, and we want it to have a slope of 4, nicely, we're just filling in numbers. So we've got y equals, and then m is your slope, times x. Plus, and then b is this part of our point. So this is the part of our point that we're actually interested in. We're not really doing anything with the 0 other than using it to say that this is our y-intercept. So that -7 is going here. And you could either write that like that, or if you prefer, y equals 4x minus 7 would also be fine. So either or. So if you've got your slope and your y-intercepts already, boom, you're done. Those ones are easy. If we've got our slope and a point that's not our y-intercept, we're going to want a thing called point-slope form, which we did a bit of back in Algebra 1. So refresher where that's coming from is if you take your slope formula, so y2 minus y1, x2 minus x1 equals your slope, which we're calling m, and you solve that for y, so we get rid of the bottom by multiplying by an x2 minus x1. These are gone. And then we're adding a y1 to get rid of that y1. Those are gone. It ends up looking like this. Don't worry, you're not going to have to repeat that, even though you should be able to. All you're going to have to do is know that this is point-slope form. I'm just going to get rid of these 2's here. So just like when we fill things into y equals mx plus b, that y and an x stayed a y and an x. When we fill things in here, this y and this x are going to stay just a y and an x. They're not going to get filled in with numbers. They're not going to have little 2's next to them. So this is point-slope form. So this is your slope, just like it is in your other formula. M is slope. I meant to look at why m is slope. It's probably Latin. And then this is your point, x1, y1. Now someone better comment in the comments why m stands for slope. Okay, so if we want something with a slope of 5 that goes through at -3, 7, instead of plugging things into slope-intercept form, we're going to plug them into that. So we've got y still equals m, that's still our slope, so our slope is 5, times this x stays an x, minus that x1, so your points go x1, y1, so that x1 is this -3. So watch out for, we have 2 negatives going on here. We have this one because it's part of our formula, and we have this one that goes with a -3. So that's minus and a -3. Now, if you'd like to change that to a plus, that's also fine. And then plus that y1 is 7. And now we're just going to make it look nice. So we're going to make this look more like slope-intercept form like we're used to seeing. So we're going to distribute this 5. And at this point, I'm going to change this minus a negative to a plus. 5 times 3 is 15. Plus 7. Combine your like terms. 15 plus 7 is 22. So you get a 5x plus 22. And boom, we have an equation for a line with a slope of 5 that goes through at -3, 7. Now we're going to make it a little bit trickier. So what if we've got a line that goes through 2 points? So first thing we're going to want to do here is we're going to want to find the slope of our line. We know how to do that. We did that yesterday or Tuesday, depending on when you're watching this. So we want to take this and we're going to plug it into our slope formula, which looks like this. It's x1. So we're going to call this one x1, y1, and this one x2, y2. And yes, you could do that in either order as long as x's are x's and y's are y's. And either both are 1 or both are 2. So you could flip-flop those and still be okay. So we got y2 is negative 10 minus y1 is 5 over x2 is negative 4. And again, watch out for this minuses because it's part of our formula. And this negative goes with the 7. So we've got both of those. Okay, negative 10 minus 5 is negative 15. Negative 4 minus a negative 7, so really negative 4 plus 7 is a positive 3. And that simplifies to a negative 5. Now watch out for, we're not done, that's just our slope. But we're almost done, because now we're going to take that slope. And we're going to take one of these 2 points. And it doesn't matter which one you pick. Generally, it's nice to go with the one that has smaller numbers, but these numbers are kind of the same size, so I'm just going to go with the first one. So we're going to take that slope and this point, and we're going to plug those into the point slope form that we were just looking at. So yeah, y equals, our slope is negative 5 times x minus x1, so minus because it's part of our formula, and then negative because it goes with that 7, plus our y1 is 5. And now we're just making it look simpler. So we're going to take that negative 5 and distribute it. So we get a y equals negative 5x. And watch out for, we've got 3 of them. So we've got this negative, this minus, and this negative. So any 2 of those are going to cancel out and going to leave us with 1 of them. So whether that's a minus or whether that's a negative, we've got 1 of them still there, and 5 times 7 is 35. Okay, almost done. So watch out for when you're simplifying this. We've got a negative 35 plus a positive 5, which is going to give you a negative 30. And again, that could either be plus a negative 30 or minus a 30. Either one's okay. So they've got an equation for a line where that goes through those 2 points. And if you're not sure, if your line ends up looking kind of funny, feel free to hop over to Desmos and graph those 2 points and graph that line and see if your line goes through those 2 points. All right, 2 other things that are going on here. And the first thing that's going on is, what if we want a line parallel to another line? So parallel lines, if you think back to geometry, parallel lines have the same slope. So I'm just going to jot that here. Parallel have the same slope. So the only part of this that we're really interested in is this negative 3. That's our slope. So we're really just going to take that slope and this point, and we're going to plug them into point slope form again. You're going to get really familiar with point slope form if you aren't already. So we're going to take our y equals, our slope is a negative 3, x minus our x1 is a 4, plus our y1, which is 5. And then we're just making this look nice. So we're going to take that negative 3 and distribute it. So we got a negative 3x. Watch out for, we've got a minus and a negative going on here. So if you want to change that to a plus, that would be a good idea. If you want to leave it as a minus negative, that's technically okay. It's not going to hurt anything. 3 times 4 is 12. And then 12 plus 5 gives you 17. Okay, the last thing that's going on is, what if instead of a line that's parallel, we want a line that's perpendicular? So perpendicular lines, think back to geometry, maybe. Perpendicular lines, your slopes are negative reciprocals. So your slopes are negative reciprocals or opposite reciprocals. backwards, but that's just a fancy way of saying that your slopes are flip-flopped. So if they're fractions, they're flip-flopped, and then one of them is positive, one's negative. So if you're starting off with one that's positive, it's going to be negative. If you're starting off with one that's negative, it's going to be positive. So for example, if we were starting off with 2, your reciprocal of that would be 1/2, but it's going to be negative. If you were starting off with, say, negative 5/7, then your negative reciprocal is going to be positive, and it's going to be positive, flip that 7/5. So if it's already a fraction, you flip it. If it's not already a fraction, you put a 1 on top of it, and then you either make it positive if it's negative or negative if it's positive. Okay, so again, really the only part of this that we're interested in is this negative 2/3. So we're going to flip it, and we're going to make it positive because it's already negative. So this is going to turn into a positive 3/2. And if you want to leave it like that, that's fine. If you're not a fan of fractions and want to turn that into a decimal, that's also fine. So that's our slope, and again, we're doing the same thing. So this is our slope, and we're going to take that slope, and we're going to plug it into point slope form. So yeah, y equals our slope is now 1.5 times x minus back here, our x1 was a negative 4. So again, watch out for minus because it's part of our formula, negative because it goes with that 4. And then plus our y1, which is 3. And again, we're just making it look nice. So we're taking this, we're distributing it. 1.5 times x is 1.5x. And again, if you left it as 3/2, that's fine. 1.5 or 3/2 times 4 gives you 6. And a minus and a negative gives you a plus. And then plus 3. And 6 plus 3 is 9. And there we go. We've got an equation for a line that goes through negative 4 or whatever that was, 3, perpendicular to that line. Boom. Okay, so hopefully that wasn't too bad. Numbers are in the description below. They're also up on Google Classroom. All of this stuff is on the Jamboard, so if it didn't come out, well, if there were points that were fuzzy in the video or you couldn't tell what I was saying, or if I stood in front of it, that's all up on the Jamboard that started on slide 11. So it's on slide 11, 12, and 13 on the Jamboard if you missed any of that. And I will see you next time, hopefully Monday, fingers crossed.